Yesterday we have completed d orbital, right? We have completed s orbital, p orbital, right?
Yes.
So can you tell me how many orbitals are there?
There are four, right?
There are four d orbital. Yes. Can you name?
Sir, the lecture I did yesterday, I'm gonna go over it today with the chemistry class we're gonna do today. So, I didn't like learn everything we did yesterday yet.
Okay. But on next class, you will learn all, right?
Yes, yes. So what I mean is like today, so we
Mhm.
have two chemistry classes in a row, right? So I'll do the stuff we covered today and yesterday, both today. So I'll do, like cover everything today on Sunday.
Okay. Inshallah, inshallah. Now d orbital, right?
Yeah.
So d orbital. Shape and names are not in A syllabus. Each shell has d orbital except first and second, right? So
Okay.
you know that you can easily find the number of electron by this formula. Number of electron in a shell, right? Number of electron in a shell by using this formula. 2n square. N is the number of shell. N is the number of shell. N is number of the shell. Let's suppose n is equal to 3. Let's suppose n is equal to 3. So 2, 3 square. 3 square is 9. 9 twos are 18. So third shell has 18 electron. 18 electron. Now D shell. This is doctor instruction. Okay. Next, there are five subshell. Five subshell or sub d orbital or sub 5 sub d orbital. As you know that shape is not in your syllabus, AS syllabus. So each or d orbital is represented by a box. Are you getting my point?
Yes.
So each box indicates orbital. So can you tell me how many electrons does the orbital occupy?
Which orbital, sir?
D orbital. You know that here we have 5 sub d orbital. So can you tell me what are the maximum number of electron does the orbital have?
That'll be 50.
550. You know that each box has maximum 2 electron. Each orbital has maximum 2 electron. So there
Oh,
are
right.
5,
Yeah. So it's gonna be 10, right?
10, exactly 10. So d orbital has maximum 10 electrons. Maximum 10 electrons. Similarly, like other down the shell or as away from nucleus, size of d orbital increases. Size of d orbital increases. size of d orbital increases. Now f orbital. Last is f orbital. F orbital. F orbital. So again, first point, shape and names are not in a syllabus. Each shell has d orbital except first, second, and third. And third. Each shell has d orbital except first, second, and third. So how to find the number of electrons? In fourth shell, 2n square. N is 4, 4 square, 32 electrons. 32 electrons. So from fourth shell, you have f orbital. So can you tell me how many? Okay, sorry. There are 7 subshell. There are 7 sub f orbital. So shape, as you know that shapes are not in your syllabus. So each orbital is indicated by a box. So can you tell me how many boxes are there? Yes. Mohammed,
So
can you tell me how many uh, boxes are there in f orbital?
an f orbital.
Yes, you know that it has 7 sub f orbital. So how many boxes are there?
If it has 7,
7. So it means you have 7 f orbital, 7 boxes.
yeah.
1, 2, 3, 4, 5, 6, and 7. 7 f orbital. There are 7 sub f orbital. So can you tell me how many maximum electrons are there in f orbital? 14. So f orbital, f is small. F orbital has maximum 14 electrons. 14 electrons. Now summary. Summary. Can you tell me how many orbits are there?
The type, sir? There's the
How
p
many?
orbital.
No,
There's
no, no,
the
no. I mean to say that how many orbitals are, how many orbits are there? Orbits. How many shell? Maximum shell.
I don't understand the question, sir. What do you mean by maximum
The
shell?
question is that you know that I told you that uh, period indicate number of shells, right? So you know
Oh,
that
right.
how
So
many periods are there?
7 shells, sir.
7. So maximum you have 1, 2, 3, 4, 5, 6, 7. So you have each shell has s orbital, right?
Yeah.
So Now, can you tell me about p orbital?
About which one? About the p orbital.
P orbital, yes. It start from first shell or second shell?
Second shell, right?
Second shell. Very good. Start from second shell. So here we have p orbital, p orbital, p orbital, p orbital, p orbital, p orbital. Now, can you tell me about the d orbital? It start from
The third shell?
third shell. So here you have d orbital, d orbital, d orbital, d orbital, and d orbital. And what about the f?
Fourth shell, right?
Fourth shell. Now, can you tell me maximum number of electron in s orbital?
In s orbital, it can, so in s is the first orbital, right?
Yes. First
Two.
orbital, 2. So each s orbital has 2 electrons. Each s orbital has 2 electrons. And what about p?
8.
No, p has 6, maximum 6 electrons.
So then how come, sir, in the second, like the second shell, there can be up to 8 electrons?
Now you can see that. Now you can see that in second shell we have 8 electrons, right?
Ah, okay, I get it
In
now.
first
Okay.
shell we have 2 electrons, right?
Yeah, I get it.
Okay. Now what about the d? Yes, can you tell me maximum d electrons?
D is the third shell, so it's going to be 3, so 2n squared, right? 2 times 3 is, no.
No, only d orbital, only d orbital, right?
Is that going to be 6 again?
No, d orbital has maximum 10 electron. Now you can see that. Yes, here we have maximum 10 electrons. So d orbital has maximum 10 electrons. D orbital has maximum 10 electrons. And F orbital?
How many does F have?
F orbital, F orbital.
I forgot, sir. Is it
Is 14.
14? So we just add 4 to each one after like S?
Yes, you can say that.
Okay.
So S orbital has 2 maximum electron. P orbital has maximum 6 electron. And D orbital has maximum 10 electron. Now, next topic is representation of electron. Representation of electron. You have 3 methods to represent electrons, right? You
Okay.
have 3 methods to represent electron. First method is electronic configuration. Electronic configuration, which you have studied in O level. Here we will discuss more advanced form of electronic configuration. Now, second one is electron dot diagram. Electron dot diagram. And the third one is orbital filling diagram. orbital filling diagram. Orbital filling diagram. There are three ways to represent any electron. Now let's start first. Electronic configuration. Electronic configuration. Yes, can you tell me what is electronic configuration? What does,
Electronic configuration refers to like the arrangement of electrons, right?
no, I mean to say that what is electronic configuration? Can you explain it in,
Like
in O
in terms
level,
of any particle?
in term of electron? Because it is electronic
Yeah, so it's
configuration.
the arrangement of electrons in the outer shell.
Arrangement of electron. Yes, 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 yes. Arrangement of
Yeah.
electron, but in A level within the orbital, right? You have studied in O level arrangement of electron
Yeah.
within the orbit,
Okay.
K orbit, L orbit, right? But in A level, electronic configuration means arrangement of electron within the orbital. So arrangement of electron within the orbital, within the orbital. Now second point is electrons are filled. Electrons are filled according to their increasing energy. As we have discussed, first shell has low energy because electron is powerfully attracted by the nucleus. As we move farther away from the nucleus, their energy increases because they are beyond the attraction of the nucleus. So electrons are filled according to their increasing energy. According to their increasing energy. Electrons are filled according to their increasing energy. Now, follow follow the following sequence to fill electron. Now listen, electrons are filled according to this sequence, right?
Okay.
But you have to follow you have to follow okay. Now look at the sequence, right?
So could you excuse me for like 5 minutes? I just want to go to the bathroom quickly.
Okay, come.
Okay, thank you.
Arun, are you in the class? Arun, are you listening my voice? Okay. So sequence to fill electron is follow this method, right? 1s2 fill first, then 2s2 fill first. After 1s2 you will fill 2s2. After 1s2 we will fill 2s2, then 2p6 3s2, then 3p6 4s2, then 3d10 4p6 5s2, then 4d 5p and 6x2. This scheme is followed. Why? Because electrons are filled according to their increasing energy. So arrow indicates increasing energy. Arrow indicates increasing energy. Isa, Assalamu alaikum.
Walaikum salam, sir.
You are too late.
Yes, sir. I'm sorry, I overslept.
Okay, you can see the recording, right? Now,
Yes.
arrangement of electrons, right? This is electronic configuration with respect to orbital, right? So we have discussed s orbital, we have discussed p orbital, we have discussed d orbital, we have discussed f orbital. Now we are going to arrange electrons within the orbital. So we follow this sequence: 1s2, 2s2, 2p6 3s2, then 3p6 4s2, and so on. Isa, are you getting my point?
Yes, sir.
Now, this is very, very important, right? Now the question is that, right, electronic configuration, right, electronic configuration of the following, right, electronic configuration of the following. Always remember this sequence: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and so on. This is increasing way. Now, our first element is hydrogen. Yes, Isa. Hydrogen has one electron. Can you tell me the configuration of hydrogen?
Sir, will it
So-
just be 1s2?
So 1s1.
Oh, okay.
1s1 because it has only one electron. Now second is lithium. Lithium is 3. So you have 3 electrons. You have maximum 3 electrons. You have 3 electrons. So in 1s, fill 2 electron, then 2s. Now you have 1 electron left, right? So 1 electron is remaining. So 2s1. Are you getting my point or not?
Yes, sir.
Now it's your turn, right? Now next is sodium. Now tell me. Yes? I am with you, try.
So first
You have 10
1s2.
electrons. 1s2. Now 9 electrons are left. Then
So 2s2.
2s2. Now 7 electrons are left. Next,
2p6.
2p6. Now 1 electron is left.
Will it? Should
Yes,
it
next
be
is,
one more
now you
electron,
can,
right?
yes, 1 more electron. So now you have 3s. Isa, one electron is left. So it would be
Yes,
3s.
one.
3s1, correct. 3s1,
Oh,
correct.
okay.
Now next is potassium. Potassium 19. Now try it again. Anyone can try. Yes. Just
Okay,
Isa.
I'll try then, I guess.
Yes,
One S
yes.
two
1s2,
and two S two
2s2, very good.
and two P six.
2p6,
8, 12, 14, 16. So 3 electrons are left.
yes. No, 3, 6, 7, 8, 9. 9 electrons are left
Oh, 9
because
electrons. Okay.
potassium is 19.
Oh, okay. So 3s2.
3s2, very good.
How many electrons are left now?
6, 7, 8, 9, 10, 11, 12, 7.
7. Okay. And 3p6
3p6,
and 4s1.
4s1. Correct. Correct.
Hi, sir, I'm back.
Now, Mohammed, we are discussing electronic configuration, right? You just follow this sequence, right? To fill the electrons. Right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. We have so many examples, right? Now we have boron. Yes. Mohammed, can you try?
Sure. So 1s2,
1s2, then
then 2s2.
2s2. Now one electron is left.
Right. So then do we just do 1s? Sorry, 3s?
No. You have 2p. After 2s, you have 2p.
So we just do 2p?
2p1. Because one electron is left, right?
Okay.
Do not put any comma or full stop, anything else between these 1s2, 2s2. Now next is aluminum. Anyone can try. Yes.
So can I
Anyone
try?
can try. Yes.
Okay, 1s2,
1s2,
then 2s2,
2s2,
then 2p6,
2p6,
then 3s2.
3s2,
Yeah, that's 6 plus 2 plus 2. So now 3p1.
3p1. Correct. Now Mohammed, your turn. Now you have silicon. Silicon 14. Yes.
1s2, 2s2,
1s2, 2s2,
2p6.
2p6,
That is 10 up until now, and then 3s2,
3s2,
and then 3p2.
3p2. Very good. Alhamdulillah, you all have learned. Now sulfur 16. Yes, Isa.
Yes, sir. So 1s2,
1s2,
2s2,
2s2,
2p6,
2p6,
and 3s2,
3s2,
and 3p4.
3p4. Very good. Now argon. Mohammed. Now argon 18.
1s2, 2s2,
1s2, 2s2, 2p6, then
3s2, 3p4.
3s2, 3p4, 3p4 or
What's
3p6?
3p6? Sorry,
3p6.
that's about it.
Okay. Now next is scandium. Scandium 21. Yes, Isa.
Yes, 1s2,
1s2,
2s2,
2s2,
2p6,
2p6,
3s2,
3s2,
3p6,
3p6. Then
4s2,
you 4s2.
12,
Very good. 4s2.
17, 18, 19,
Then
20. 3d1,
3d1. Very good. Very good. MashaAllah. Next is iron 26. Yes, Mohammed.
1s2, 2s2, 2p6, 3s2,
1s2. Very
3p6,
good.
and then
Very good.
4, and then 3d. What's the formula? Could you show me the formula again, please?
Yes, this is
Right, and then
3D.
3d6.
3d6. Very good. 3s2, 3p6, 4s2, 3d6. Now, second last question, right? Zinc 13. Yes, Isa.
yeah. Sir, won't it just be the whole formula?
You can see here. This is the formula.
Yeah, but 3d should become 10.
Yes, here this time 3D become 10. Correct. So this is zinc. Now last, cobalt 27. Yes, Mohammed, this is the last one, right?
Yeah. So everything repeated again, but in the end,
Again and
it's
again.
3d7.
3D7. Okay, very good. Now a test for both of you, for all of you, right? Now chromium 24. Anyone can tell me the electronic configuration, right? Yes. Anyone. This is your test.
The
Yes.
platonic,
Yes, this is
that would
chromium.
be the
It's
proton,
no, no. Just fill the. Just tell me the electronic configuration as
Oh,
usual. Yes. One
okay.
is two.
So 1s.
Yes.
So in this case, everything will be repeated again, but it'll be 3d
Yes. Yes.
4.
3D4. Okay.
Yeah.
1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Yes, Isa, what is your
Yeah.
opinion? Either this one is correct, this one is correct, this one is right or wrong?
It's correct.
Correct. But this is wrong. This is exception, right? This is exception. As we have discussed, d orbital has, as we have discussed, d orbital has maximum how many electrons? Yes,
10.
10 electrons. So if this electron, jump, 4s electron jump to 3d, if 4s electron jump to 3d, it become it become 3d5 and 4s2 become 4s1. Now d orbital is half filled. You know that d orbital has maximum 10 electrons. After shifting off one electron from 4s, d orbital is half filled, and half filled is more stable. So driving force of jumping off this electron is stability. Chromium is exception. Why 4s electron is jumped to 3D and 3D4 become 3D5. Now 3D orbital is half filled, half filled is more stable. That's why electronic configuration of chromium is this. Are you getting my point or not?
Yes, sir.
This is half filled. So half filled is more stable. So right, correct electronic configuration. Correct electronic configuration.
Sir, so this half-filled exception is only for chromium.
Yes, only for chromium, right? Because in your syllabus you have only two exceptions, right? First is chromium, and the second one I will discuss later.
Okay,
So
sir.
electronic configuration of chromium is 4s1 3d5 but not 4s2 3d4. Why? So this is the reason. 4s electron jumps to 3d orbital. 3d orbital. 4s2 becomes 4s1. 4s2 become 4s1. 3d4 becomes 3d5. So half filled is more stable. Half filled d orbital is more stable. Half filled d orbital is more stable. That's why chromium has half filled configuration. That's why, or you can say that chromium has half filled chromium has half filled chromium has half filled configuration. Are you getting my point or not?
Yes, sir.
Okay. Next is, can I move forward?
So just
Yes,
1
Bidin.
minute.
Okay, okay.
Yes, sir, you can move on. Sir, will you
Okay.
give us these notes for printout after the chapter?
Yes, after the completion of the chapter, I will inshallah provide the full PDF of the file.
Okay.
If something is missing, so you can copy from this PDF. Now, next is copper. Copper is 29. Yes, anyone tell me its electronic configuration?
So is copper an
One.
exception or not?
Maybe. Now, first just tell me the configuration.
Everything is the same except it's
So
going to be
3D9, 3D9, right?
yeah.
Okay, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. So no, you can see that whenever d orbital has 9 or 4 electrons, 9 or 4, for 4s electron jump to 3d4, right? Similarly, if you have 9 electron, this configuration is wrong. This electron jump to 3d9. And the correct configuration would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. This electronic configuration is correct. This electronic configuration is correct. So, correct configuration of copper is 4s1 3d10, not 4s2 3d9. Why? Because 4s electron jumps to 3d, four s two becomes 4s1, 4s2 becomes 4s1, 3d9 becomes 3d10. And the statement is that completely filled completely filled d orbital completely filled d orbital is more stable. Are you getting my point or not?
Yes, sir.
Now, first exception, in your syllabus, this is your first exemptions. CR. CR is your first exemption. C stand for copper and CR stand for chromium. So copper, chromium are exception. Copper is completely filled. Completely filled. And chromium is half filled. Do you have any question?
No, not
No,
so
sir.
far.
Isa Harun, do you have any
Yes,
question?
sir. No.
Okay. Now look at all electronic configuration again. Now Isa, can you tell me hydrogen, electronic configuration of hydrogen ends with which orbital?
There's the s orbital in it.
So hydrogen is called S block element. S block element. Yes, what about the lithium? Yes,
Is it also in the s orbital?
yes. So again, this is called S block element. And what about the sodium? Yes.
It is in the p orbital.
No, sodium.
Oh yeah, s orbital. My fault. My fault.
So again, it is S block element. What about the potassium?
S block.
S block. So again, S block element configuration ends with S. Now, what about the p orbital? Oh, sorry. What about the boron? Yes. Configuration ends. Yes, beta. Configuration ends
And P.
P. So this is called P block element. Boron is P block element. And what about aluminum?
P. P block.
Again P block. And silicon.
P block again.
Okay, all ends with P. So P block element. Now what about the scandium?
Scandium. It's a
Yes,
D block element.
it's D block element. Correct. Scandium is D. Iron is D. Zinc is D. Cobalt is D. So all are D block elements. So in the periodic table, we have four blocks. S block, P block, D block, and F block. S block, P block, D block, F block. Because electronic configuration ends with S, if electronic configuration ends with S, then the element is called S block element. If configuration ends with P, it is called P block element. If configuration ends with D, it is called D block elements. If configuration is end with F, it is called F block elements. Can I move forward?
Yes, you
Yes,
can.
sir.
Okay. Now look at the periodic table. Now this is periodic table. Yes, this is the periodic table. So you can see that red one indicates S block. These red are S block. S block element. Blue one indicates P block. P block. And yellow one is P block. Sorry. This one is D block and this one is P block. This is P block and the blue one is D block. My mistake. D block and the green one is F block. Because configuration ends with S, configuration ends with P, configuration ends with D, configuration ends with F. So if the configuration ends with S, then these elements are called S block elements. Group 1, group 2 S block elements. P block elements if configuration ends with P. Group 13, 14, 15, 16, 17 and 18 are P block elements. Okay, can I move forward, Bide? Okay. Do you have any question regarding electronic configuration of Any substance, any element.
Wait, sir, how will we get an F block element? Because this expression that you gave us ends with 3D, so it will never end with F.
Now you can see this pattern, right? Follow
Yeah.
this sequence: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, then 4f.
Oh, okay.
F block is not in your syllabus.
Oh, it's not? Okay.
F block is not in your syllabus. So don't worry at all.
Okay, thank you, sir.
Now next is marking scheme and your electronic configuration. You may confuse to see marking scheme, right? So marking scheme and your configuration. Now can you repeat the electronic configuration of iron? Isa, can you try again?
Okay, sir.
Yes. Just tell me.
Wait,
1s2, Shabash.
yeah, 1s2, 2s2,
2s2. Yes,
2p6,
Isa. 2p6.
3s2,
3s2.
3p6,
3p6. 4s2.
4s2.
And then
Wait, I think this is 20 so
3d6.
far. So 3d6.
3d6.
Yeah,
Right? This is
yeah.
correct. But sometime in marking scheme, electronic configuration is written like this: 1s, 2s2, 2p6. First, write all three. So move this one near the 3, 3d6, and then 4s2. So both are correct. Both are correct. Don't worry at all. Mohammed, are you getting this point?
Yes, I am, sir.
Yes, Isa.
Yes, sir, I'm getting the point.
Okay. So both are correct. This, if you write this electronic configuration directly, so you may write wrong electronic configuration, right? That's why I prefer write this electronic configuration, and then you can try, you can change it. You can change it. Now, chromium. This is MS in marking scheme. Now, next is chromium. Chromium is 24. So 1s2, 2s2, 2p6, 3s2, 3p6. You know that it is half filled. So it is 4s1, 3d, 5. Now, can you rearrange? Anyone can rearrange it? Yes.
Yes, I just put 3d5 with 3p6 and then 4s1 in the end.
Very good. Very good. 1s2, 2s2, 2p6, 3s2, 3p6, 3d move here. So 3d5, 4s1. This is in the MS. So both are correct. Now, my first question regarding electronic configuration. Now you can see the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6. Why 4s come before 3d? Why 4s come before 3d? Why 4s come before 3d? Yes, can anyone tell me? Why 4s comes before 3D? Yes, Vijay. Can anyone tell me why 4s come before 3D? Any idea?
Not sure, sir.
Okay. You know that this is for 2 marks, right? You know that electrons are filled according to their energy. Electrons are filled according to their energy. So if 4s come first, it means its energy is less than 3D. Are you getting my point or not?
Yes.
So in the beginning of today's class, I told you that electrons are filled according to their energy. First shell is near the nucleus, and first shell is under the influence of nuclear attraction. That's why first shell has low energy. As we move further away from the nucleus, energy of the electron increases because they are far away from the attraction of the nucleus. So 4s energy is less than 3D. So for 2 marks, for first mark, you will write electrons are filled according to increasing energy. Electrons are filled according to increasing energy. 4s energy is less than 3D. Now another question. Why 5s? Why 5s come before 4D? Yes. Can you tell me the answer?
So because 5s energy is less than 40.
Exactly same answer. Because electrons are filled according to increasing energy. 5s energy is less than 4D. 4D. Now this is all about the electronic configuration. So as we have discussed, we have 3 methods, right? So this is all about the electronic configuration, right? I think just a minute, right? One more question or one more heading. Electronic configuration. Electronic configuration electronic configuration by noble gases. Now, you know that noble gases are helium, neon, argon, and krypton. These gases are noble gases. These gases are noble gases. Now, electronic configuration with respect to noble gases. First element is sodium. Second element is chlorine. Third element is iron. Fourth element is chromium. Then copper. Yes. Normal electronic configuration of sodium is, yes, Isa, can you tell me?
Yes. 1s2, 2s2, 2p6,
1s2, 2s2, 2p6,
3s2.
3s1, right?
Yeah.
So can you tell me the number of electron of sodium?
11.
11. So which noble gas is nearest to sodium?
Neon.
Neon. So you replace all, right? And just write neon, 10 electron, and then remaining 3s1. This is by noble gas configuration. Are you getting my point or not?
Yes.
Now, again for chlorine. Yes, Beta. Can you tell me electronic configuration?
Yeah. 1s2, 2s2, 2p6,
1s2, 2s2, 2p6,
3s2.
3s2,
That's 8 and 12. So 3p5. Wait.
3p5.
Yeah. Yeah.
Okay. Now, which element is nearest? Or below,
Argon.
below 17, right?
Below 17. It
Below
would be
17.
neon.
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 Neon is the nearest, right? So
Yeah.
again, neon with the 10 electron. Yes, how many orbitals are left?
3s2 and 3p5.
Very good. 3s2 and 3p5. Ahmed, are you getting this point or not?
Yeah, I'm sure.
Okay. Okay. Now iron. Tell me the electronic configuration of iron.
1s2, 2s2,
1s2, 2s2, yes.
3s2,
2,
3p6,
okay,
2s2,
2p6, 3s2, 3p6,
yeah,
4s2, then
4s2, and then 3d6.
3d6. Now, which element is nearest?
Argon.
Argon. So, argon is 18.
So that's going to be so the remainder is going to be 4s2 and 3d6
Very good. 4s2,
and 3d6.
3d6, 3d6. Very good. So, here we have neon. Here we have argon. Now, tell me the electronic configuration of chromium. Yes, 1s2, 2s2. Isa.
Yes, sir. It will all be the same except the last two orbitals will be 4s1 and 3d5.
Okay, 2p6, 3s2, 3p6, 4s.
1 and 3d5.
Very good. 4s1, 3d5. Very good. So, which element is nearest?
Argon.
Argon. So, argon is 18. No. Here we have argon. So, electronic configuration is argon 18, then 4s1, 3d5. Yes, last. Yes, beta. For copper,
Yes, sir. Okay. 1s2,
1 is
2s2,
to
2p6,
2 is to 2p6. Yes.
3s2,
3 is to 3 is
3p6,
to 3p6.
and 4s1 and 3d9.
3d9 or 10?
Or 3d10.
3d10. Completely filled, right? This is exception.
Yeah.
Yes. Now tell me the electronic configuration with respect to noble gas.
8, 6. Okay, it will be copper 4s1 3d10. I
4s1,
mean
3d10.
argon 4s1
Argon
3d10.
18,
Yeah.
4s1, 3d10.
Yeah.
This is all about the electronic configuration by noble gases. Next, beta, I explain in detail, right? Because in your past paper you have very difficult questions sometimes, right? That's why I will give the lecture in detail. So electronic configuration, now electronic configuration of ions. Yes. So right, important point for it, right, important point for it, DI, doctor instruction. First, write electronic configuration of neutral atom, then add or remove electrons. First write the normal electronic configuration, then remove the electron. Now first question is iron 26. Yes, first write the electronic configuration of iron 26, right? So electronic configuration of iron 26 is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Now can anyone tell me which orbital is valence orbital? Which shell is valence shell in iron 26?
Sir, is it the last one?
Last one is 3d, right?
Yes.
Are you sure? Yes, Mohammed, which one is the valence orbital?
The last one, right?
Okay, wrong. The last one is
Oh,
not, but the fourth one. You know that the fourth shell is the valence shell.
2, 3.
So 4s2 is the valence shell. You know that fourth is the valence shell. So remove 2 electrons from this. Now you have and 3p6. So electronic configuration of iron plus 2 is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4p6, 4s2, 3d6, right? Sorry. So electrons are removed from valence shell. electrons are removed from valence shell. Now, Isa, chromium plus 3. Yes, chromium. Yes, Isa, can you
Yes.
try it?
Yeah. Okay.
Yes.
1s2,
1s2,
2s2,
2s2,
3s2, 3p6,
2p6, 3s2,
4s1,
3p6. Very good.
and
4s1, 3d, 5.
5.
So, which one is the valence?
The fourth one.
So, one electron is removed from 4s and
And 2 electrons from 3d.
3d. 2 electrons from 3d. So, what would be the new electronic configuration?
It will be 1s2, 2s2, 2p6, 3s2, 3p6, and
Hmm.
3p3. I mean 3d3. Yeah.
3p6 and 3d, 3. This is chromium 3 plus. So, one electron from 4s and 2 remaining from 3d. Now next, copper 29 plus and then copper 2 plus 29. Yes, Isa, try this one.
Okay, sir. 1s2,
1s2,
2s2, 2p6, 3s2,
2s2, 2p6, 3s2,
3p6,
3p6, yes,
4s1, and 3d10.
4s1, 3d, 10.
Then
Very good. Yes.
so now we'll
Now,
just
now remove one electron.
yeah, just remove 4s.
Remove 4s.
And for the second one, we should also remove from 3d one electron.
So, one electron from 4s and
One from 3d.
one from 3d. So, it becomes 1s2, 2s2, 2p6, 3s2, 3p6 and 3d10, 1s2, 2s2, 2p6, 3s2, 3p6 and bit it 3d,
3d9.
39.
3d9, 3d9. Very good. This is electronic configuration with respect to or by considering ions, right? So this is all about today. So should I start? Should I start electron dot diagram or not?
Sir, it's up to you. Do you think you can finish it in 9 minutes of the class remain?
Yes, Mohammed. What is your opinion? Electron dot diagram, right? This electron dot diagram. Hmm. Okay, let's start electron dot diagram. Next is electron dot diagram. Electron dot diagram. Now you consider that electrons are represented by a dot. In electron dot diagram, electrons are represented by dots. Electrons are represented by dot. Electrons are represented by dot, right? Point number 2, only valence electrons are considered. Only valence electrons are considered. Only valence electrons are considered. Next, group number indicates valence electron. Always remember group number. Group number means, let's suppose you have sodium. So group number is 1. If you have calcium, group number is 2. If you have chlorine, group number is 7. So group number indicates valence electron. Now our first example is oxygen. Now can you tell me how many electrons are there? Can you tell me group number of oxygen? Yes.
6, right?
Group number is 6. So valence electron 6. So this is oxygen. 2 electrons, 2 electrons, and 2 electrons. These are called lone pairs. Without bonding, these are called lone pairs. This is called electron dot diagram. Example number 2 is nitrogen. Nitrogen. Yes, can you tell me the group number?
Nitrogen is in group 5.
Nitrogen is in group 5. So 5 valence electron. So here you have nitrogen. So 5 electrons. 1, 2, 3, 4, and 5. This is called lone pair, and this is called lone unpaired. This is unpaired. This is lone pair. Unpaired and lone pair. Okay. Now new third one is, this one is second. Third one is orbital filling diagram. Orbital filling diagram. Orbital filling diagram. So I think orbital filling diagram is very lengthy. So we will discuss in the next class, right?
All right,
Do you
sir.
have any question?
No.
No, sir.
Okay.
Alhamdulillah.
Okay, alhamdulillah, alhamdulillah. So inshallah, in the next class, I try my best to complete this chapter, right? And then I will give you the past paper, and then we will discuss past paper, right?
Right.
Okay.
Okay.
Allah Hafiz.
Allah Hafiz.
Allah Hafiz.
Laugh is here.